Hi, welcome to the Scripps Center for Metabolomics. I'm Brian Helmers. With me is Caroline Johnson, here to talk about her paper, Metabolism Links Bacterial Biofilms and Colon Carcinogenesis, recently published in Cell Metabolism. What inspired you to do your work?
Well, it really came from a collaboration with Cynthia Sears at Johns Hopkins University, and what they saw was the association of bacterial biofilms on colon cancers. And when they looked at people that were just going for colonoscopy screening, about 100 people, they saw about 15% of them had these biofilms, but they were located anywhere in the colon. But it was only in colon cancer that they saw that about 50% of people had a biofilm, and they were only located on the proximal colon. From our perspective, what we wanted to see was whether, when these biofilms were present, whether there were any metabolites that were related to biofilm presence and that could be affecting the metabolism of the tumour.
Okay, so what were your major findings?
So using 4 different metabolomic platforms, including our on-targeted global metabolomic workflow, a targeted validation approach using MRMs, a targeted imaging approach where we could see the localization of the metabolites in situ called NIMS, and finally a global isotope metabolomic approach, we were able to see that even comparing normal to tumour tissues, we saw a very large metabolic dysregulation, but the largest metabolite that was changed tenfold was diacetylspermine, and this metabolite is involved in the polyamine pathway, and it's known that polyamines can increase cellular proliferation. But when we looked at biofilm negative versus biofilm positive tumour tissues, we saw a 4-fold increase in this metabolite. So doing further biochemical tests, including looking at a cohort of patients that received 24 hours of antibiotics, so it's likely that the bacteria are taking up this metabolite and using it to build the bacterial biofilms, and then the biofilms themselves are conferring a pro-inflammatory and pro-carcinogenic effect, as we saw through immunohistochemistry and immunofluorescence experiments. So it seems that the bacterial biofilms are propagating the cancer, and we end up with this vicious cycle of cancer growth.
Okay, great. So what are your future research goals?
Well, what struck me about the study was the fact that the biofilms only form on the proximal colon in colorectal cancer patients. And I was thinking about the environmental conditions in this area, and the fact that there's a large number of dietary metabolites present, including things like butyrate at millimolar concentrations that come from fibre ingestion. And these metabolites are co-metabolized by the microbiota, so I'd like to really see the interplay between the genetic background and the disease status, and also the dietary intake of the patients.
Great. Anything else to add?
That's all.
All right, thanks for talking with me, Caroline.